Hi, I am Professor Suhas Ambulekar and welcome all to the today's session of our subject, that is Design of Machine Element 1. In the previous sessions, we have covered the cotter joints, its application and the design procedure of the cotter joint. In the today's session, we will see the knuckle joints, its applications and the design of knuckle joints. A knuckle joint is used to connect two rods which are subjected to tensile stress or tensile forces. Knuckle joint is a tensile joint. However, if the joint is guided, it may support a compressible load also. The basic component of knuckle joint are: first is eye, next fork, and third is the knuckle pin. Here you can see the three parts, it is eye, fork and the knuckle pin. The eye is the end of one rod is formed into an eye or single eye or rod. Next is fork. The other rod is formed into a fork or double eye with an eye in each of the fork. The single eye is inserted into the fork, and after aligning the holes, the knuckle pin is inserted through them. Knuckle pin has a head at one end, and at the other end it is secured by a collar and a taper pin or split pin. In this diagram, P is the tensile force applied on the side of the knuckle joint. The material for knuckle joint is usually plain carbon steel or wrought iron. It may be cast or fabricated or forged. Now we will see the design part of the knuckle joint. Before that, we will see some of the basic terminology in the knuckle joint. So here P is the axial tensile force on rods, as we have seen in the figure. Small d is the diameter of the rod. T is the thickness of the single eye. Capital D is the outside diameter of the eye. dP is diameter of the knuckle pin as shown at the bottom of the figure. T1 is the thickness of the fork, while DH is the diameter of pin head at the top of the fork. You can see it. And finally, the T2 is thickness of pin head and collar. So moving ahead with the design procedure of knuckle joint. First we will find out the parameters to be calculated, that is, first is diameter of rod D. The stresses induced on the knuckle joint is sigma T, that is tensile stress, sigma C is compressive stress, and tau is the shear stress. These are the stresses induced on the knuckle joint. So for the diameter of rod D, we need to calculate according to the formula sigma T, that is tensile stress, equal to P, that is axial stress, divided by pi by 4 d square. So D is the diameter of rod here. Using these equations, we can find the unknown diameter of rod D. The second part is diameter of knuckle pin, that is dP. So as shown in the figure, diameter of knuckle pin dP can be found out using the equation of direct shear stress. that is tau equal to P, that is axial tensile force, upon 2 into pi by 4 dp square, where dp is diameter of knuckle pin, can be find out using these equations. Moving ahead with the third parameter, that is thickness of the single eye. The stresses induced on the thickness of the single eye are crushing stress and or bearing pressure PB. So using these equations we can find out the thickness of the single eye T as shown in the figure. So for that we will equation is sigma C or PB equal to P, that is axial tensile force, divided by dP into T, where dP is the diameter of the knuckle pin and T is the thickness of single eye. So using this equation we can find out the unknown parameter, that is thickness of single eye T. Another stress induced on the thickness of single eye is, that is by proportion. So using the empirical relations, that is T equal to 2.25 D, we can also find out the thickness of single eye T, where D is the diameter of the rod in mm. So using both these equations we can find out the T, and T is taken as larger of the two values, whichever we get. The next part is thickness of fork T1. The stresses induced on fork, that is crushing stress sigma C. So using that equation to find out the thickness of fork T1 as shown in the figure, the equation is sigma C or PB equal to P axial tensile force divided by 2 into dP into T1. So dP is diameter of the knuckle pin. So from here we can find out the T1. The next empirical relations to find out T1 is as T1 equal to 0.75 D. D is diameter of the rod in mm. So using these two equations we will find out the T1, and the larger value of T1 between these two is taken for the next calculations. Next is design procedure of knuckle joint, that is fifth parameter, outside diameter of eye, it is capital D. The stresses induced and on the outside diameter of eye is tensile stress sigma T and direct shear stress tau. So using the tensile stress sigma T equation, that is sigma T equal to P upon D, that is outside diameter of eye, minus dP, that is diameter of knuckle pin, into T, that is thickness of the single eye. Here we can find out the capital D, outside diameter of eye. According to direct shear stress tau equations, we can also find out the capital D, that is tau equal to P upon D minus dP into T. So using these two equations we will find out the outside diameter of eye D, and we will take the larger value among between these two for the calculation. The next part is stresses in the fork. The two stresses are there, that is tensile stress sigma T and shear stress tau. So sigma T equal to P upon 2 into D minus dP into T1. Here T1 is the thickness of the fork, and next is shear stress tau equal to P upon 2 into D minus dP into T1. So for safety we will take sigma T less than sigma allowable, and tau shear stress is less than tau allowable. The applications of the knuckle joints are: a knuckle joints is used in tension link in a bridge structure. It is also used in link of a roller chain as shown in the figure. The knuckle joint is also used in tie rod joint of roof truss and of jeep crane as shown in the figure. Thank you.